Hello, and today I'm going to be teaching you how to make this pathfinding system that will let you run one line of code that's really modular and easy to understand. With that out of the way, let's get straight into it. Alright, so let's just get straight into it. So the first thing we're going to need is a script and a module script. Now I'm going to name this something like pathfinding our module script. And the reason why we're using it as a module is so we can make it really easy to use in other scripts. So I'll show you what I mean here. So we'll actually call this module. So pathfinding require script wait for child pathfinding. And now that we've actually got our pathfinding module, we'll make a function for something like walk2, and we'll give it the NPC we want to move. So like NPC and a position. And writing this one line of code will do a bunch of code in the background, and it makes this really easy to like just reuse this. So we can just run this one line of code and it does it all for us. But yeah, with that out of the way, we'll name this pathfinding and return pathfinding. We're gonna have that function that we had earlier. So let's say move2. And when we call this function, this will be the function that actually moves the NPC. So we'll make that. And then we're gonna need our services, of course. So the first service we're going to use is the run service. Now you might be wondering, why do we need the run service? And that's because later in the code, I'm going to create paths to see where the NPC is actually moving, so we can actually visualize and see what's happening. So we'll use the run service, and we're going to use this to check if they're in studio, because we don't want to visualize where they're moving when they're actually playing the game, of course. And then we're also going to need the tween service. So let's get the tween service, game get service, tween service. And we're also going to need the pathfinding service, of course. So pathfinding service equals game get service, pathfinding service. Now, from there, we need an NPC and a position to move to. So I'll just import my current character. So let's do rig builder. Let's do R6 or R15, doesn't really matter. I'll just do R6. Get my avatar, and I'll just name this something like NPC, and I'll move this into the replicate storage for now. Let's get that in our code. So let's write replicate storage equals game get service replicate storage, and we also need this NPC. So let's write NPC replicate storage wait for child NPC, and we'll clone it because we'll get multiple, I guess. And we need a position or part we want to move to. So I'll just make it a part, for example's sake. And we'll actually pass that into here. So we'll do workspace.part.position. And then we actually need our NPC. So we'll pass our NPC. From there, we can actually just go straight into writing the module. So like we passed here, we passed a NPC or a character in our position. So we'll make two parameters, one called character, one called position. And then from there, we're going to need the humanoid of the NPC. So we'll do character, dot humanoid like this. And then we're also going to need the humanoid root part. So humanoid root part equals character dot humanoid root part. Now we probably should use wait for child on these. So let's do wait for child. Humanoid root part. Just in case the humanoid root part hasn't loaded in time. And then from there, we need to actually create our path for the pathfinding. So we can call pathfinding service and then create path. Now, this takes a parameter called agent parameters, which I'll put up on the screen what all the different parameters look like. These include things like if the NPC can jump, if the NPC can climb, stuff like that. I'm just going to keep this empty because I won't be using it, but you'll simply just create an array and then write what you want to do. So for example, agent, if you want your NPC not to be able to jump, you'd write agent can jump equals false, and I'll disable it from being able to jump. But I'm just going to keep this empty because I'll just leave it the default. From there, we actually need to compute our path or calculate where they're going to be going. So we'll do that in a p-call just in case something doesn't go right. So equals p-call function. Whatever runs within this p-call, if something goes wrong, it won't error the rest of our code, and it'll actually give us the reason why it errored and if it actually worked as two variables. So we'll write we'd write path and then compute async, and then we'll compute the current position of the character, so humanoid root part.position, and where they're going to be moving, which is the position we passed. And then up here, we're going to add character.humanoid root part. Actually, we already have the humanoid root part. Humanoid root part set network owner set network owner to nil. Now, the reason why we need to set the network owner of the character or the part is if you don't set it to nil, the game is gonna fight between who owns the NPC, so the server or the client, and you'll see your NPCs start to stutter if you don't set the network owner to nil. And I'll give an example of that on the screen now, what that looks like with it on and with it off. When you get close to the character. So yeah, make sure you set that to nil. After that, we need to check if it's a success. So if success, and we can also check the path status. So if path status is nm.pathStatus success, we can then continue the rest of the code. If not, we'll return something like false, like it didn't work, like an error or something like that. We can also return the error if we want to. If it did work, we can create waypoints for them where they're gonna move, and this will be like the parts it'll calculate. So for example, imagine this is the end location. It'll create a bunch of waypoints towards this part, something like this. And then it'll walk to all the waypoints until eventually reaches that part. So that's what the waypoints are doing. So you do local waypoints equals path, and it'll get the waypoints, so get waypoints. And then we're gonna have a bunch of variables that are gonna keep track of what's going on for my NPC moving. So they're gonna start at waypoint 2, and this will gradually go up as they go to each waypoint. And they're gonna start at 2 because the position they're starting at is already waypoint 1. So we want them to immediately move to the next waypoint, not wait. So do waypoint 2, move 2 equals nil. And a lot of these I'll explain in a second, but we need to just write them out for now. Last location, and this will just be vector, just like an empty vector, something like this. And then from there, so we're gonna set our move to an event that we'll be keeping tracking of. So move to finished. And we do connect function and then reached. And what will happen is each time they get to the next waypoint, it'll then run the next, they'll just start moving to the next waypoint, and we can keep track if that is currently going on, because if they get stuck, we're gonna have to cancel this move to and either try again or just teleport them to the location. So we can do if reached and waypoint is smaller than the total waypoints. So if they've reached the next waypoint, so let's say they've reached that second, let's say we have a bunch of waypoints here. Let's say we have 2 like this. I'll create 3. Let's say they've gone from this waypoint to this one, they've reached this waypoint. We're gonna then, if they haven't reached the last waypoint, which is what we're checking here, if the current waypoint is lower than the total waypoints, and they've reached this waypoint, we're gonna then start to get them to move to the next one. So we'll actually add 1 to waypoint once they've got to the previous one, and then we'll get them to start walking to the next one. So to write humanoid move to our waypoints array, the current waypoint we want them to move to, and the position of that waypoint, and that'll get them to start to move. Now, if they've actually reached the last waypoint, let's say this, or their final location, we can then stop this. So we can write move to disconnect and move to equals nil, and that'll delete this entire move to thing, and then we can continue with the rest of our code. We're also going to want them to immediately start moving to the next waypoint, so we can do waypoints, the second waypoint. This is the one we want to get them to moving, because we don't want them to, they'll start at this waypoint, but we don't want them to just take time to walk to where they already are. We want them to immediately start walking to the next one. So that's why we write waypoints 2, and then we'll start moving to the position of that waypoint. From there, while moving, we want to check if they get stuck or not. So we'll do a magnitude check. We'll check the distance they are from their last location, if they've actually made any progress to moving towards to where they want to move to. So we'll do humanoid root part.position minus last location, and this is that empty vector we had earlier. And then dot magnitude, and I'll do something like 5 studs. So if they've got, let's say, to this waypoint, and there's a big wall in front of them, something like this, they're gonna get stuck on this wall, and because they haven't moved anywhere in like the last, let's say like we'll check every 3 seconds. If they haven't moved anywhere in 3 seconds, then we'll just teleport them to where they're actually meant to be if they get stuck. So this is what we're checking, if they've moved like in 5 studs distance in the last 3 seconds. So if they haven't moved, then we're gonna disconnect this from them trying to move there. And we'll also set that to nil like we did up here, set that to nil. And then we're just gonna teleport the character. So let's make a function called function teleport character. And we'll just give the character where they're going. So character and position as well. And then we'll call that function down here. So teleport character, and we'll give it the character and the position, of course. And then I'll get back to this in a second. But for now, we're going to write last location equals humanoid root part dot position. And this will update, let's say every 3 seconds. So every 3 seconds it'll run this. So it'll check if they've moved more than 5 studs. If they haven't, then we'll teleport them to, they got stuck, we'll teleport them to where they haven't been. If they have, we'll just update their last location and check again. So if they have kept on moving, then it's fine. We'll just, set their last location, and then we'll run this again and check again. From there, we can actually write our teleport character function. So what we'll do is get the humanoid root part again. So what we can do is copy this line of code here. We're gonna need the humanoid root part. And then we can very abruptly just teleport them to the location. But what I'm gonna do is fade them in and out so it doesn't look like too jarring. So we'll make another function called like tween character. And we'll pass the character and the transparency they want to be. And we'll call this function. So we'll write tween character and we'll pass the character again. And then from there, we can loop through within inside the character. So for underscore v in pairs, character get descendants. And what this will do is we'll get every single part within the NPC character. So all these parts here. And what we'll do is check if it's actually a part. So if v is a base part. The reason why we need to do this is we need to check if it's actually a part of the character, not something like this humanoid or the body colors or the animate script, because they don't have transparency values. Only these parts have transparency values. We also want to check that it's not the humanoid root part, because the humanoid root part we need to keep transparent all the time. So we'll do v.name doesn't equal humanoid root part, like so. And then we'll actually start to tween these parts. So we'll do tween service, create v, and we'll do something like tween info. For some reason, tween info is not coming up, but tween info 0.5. I think that's because I didn't do a comma there. There we go. Tween info, we'll do 0.5 seconds is how long it takes for the tween to complete. And we'll set that transparency to what we pass. So transparency, and then we'll play that tween. So what we can do there is tween character, and we'll make them transparent. So we'll set it to 1. We'll then wait, let's say, a second before teleporting them. So we'll do humanoid root part dot cframe, and we'll set their cframe to the last location, cframe.new position. And then after that, we will tween the character back. So tween service character, and we'll tween them back to 0 so they come back. This was accidentally set to lowercase, so we actually need to make this capital, because capital transparency, like this, is the name of the property we're actually trying to do. So you can see here, transparency. We need to make sure that's a capital T. From there, we can return true after everything's done, just to say everything did work and we're done. And we can click play here, and you'll actually see our character start to walk. I'll add a little bit of a wait so we can actually load in time before we see it happen. You see our NPC here. It's going to start walking to our endpoint here. Now, if we run this again, because we've created that system to check if they get stuck, we can actually see it work. So we can like close this off, and let's say they get stuck on this wall. They can't actually make it to the end location. After about 3 seconds or 5 seconds, they'll fade to nothing like this, and they'll appear on the other side where they're actually meant to be. So even if they do get stuck, they'll end up making it to their end location because of the system we made. And yeah, that's basically pathfinding done. This is the pathfinding module. You can just run this line of code whenever you need to for any NPC, any character. You can put this in a loop, have as many as you want going on. And yeah, that's basically pathfinding. And I'll see you guys next time. Goodbye.